All right, so here's the screencast that I was supposed to give you guys last night. Now, this is kind of a weird time warp because I'm doing the screencast while you guys are listening to me, and then you're going to listen to this later on. Say hi.
Hi.
Oh, isn't that weird? That's you saying hi. What are you going to do? Oh my God. That is awesome. All right, so we're going to talk about, I'm going to lock the screen. We're going to talk about the importance. What are you looking at? Do your damn work. Of sex. The importance of sex. Now, before I talk about why sex is important, I actually need to talk to you about why asex is important. Asexual reproduction. If you recall, you guys did some microscope work looking at asexual reproduction. And then you did a research assignment that you had to turn in about plants undergoing asexual reproduction. So clearly, there's a lot of organisms out there that do asexual reproduction. So there must be some good about it. And in fact, there are. Number one, you can produce genetic clones. Now, that can be a really good thing because if you think about it, if you're in a static environment, an environment that doesn't change, why would you want to change yourself? If what worked for you works, then what works for your children also is going to work. So being able to produce something that works in the current environment and then will work in the next environment because it hasn't changed is not a bad idea. The other thing about asexual reproduction is that it requires very little energy. So very low energy cost. You don't have to find a mate. You don't have to create an egg. You don't have to incubate that egg. You don't have to undergo the gestation period. All those things which are incredibly energetically costly. And then lastly, no need to find a mate. That's not a big deal if you have a high population of organisms or a high population density. But if you're spread out and in different areas miles away from another organism or population of organisms, that might prove to be an issue, a barrier for your reproduction if you had to do sexual reproduction. Okay, so those are the three main reasons why asexual reproduction is so good. So given that, why would you want to have sexual reproduction? I'm going to pause this now because I got to make sure I listen to you guys as you do this quiz. Okay, so now I'm at home instead of trying to do this in class while you guys are working. So let's talk about the benefits of sexual reproduction. The number one thing, of course, is that it leads to variability. In the in successive generations. So that means if things are changing, you can actually change yourself to, let's see, did I screw this up? Hold on. You can't even read. So I'm sorry, that last, maybe you could read it, sorry. So if you have a change in the environment, then obviously this is going to be beneficial to you, but it also could be hurtful. Obviously if your environment doesn't change much, then why would you want to change yourself? Why would you want to vary? But there are subtle changes that you might want to make that could be beneficial. So what this allows for is that you have a faster rate of evolution per generation. Did you learn that, Abigail? Faster rate of evolution per generation? Now, that doesn't necessarily mean that you're going to evolve faster. This is an important distinction to be able to make. It's per generation, it's faster. And what I mean by that is that if you think about human beings, our generation time is about 25 years. So in 25 years, you can go through literally millions of generations of bacteria. All right? So in the end, bacteria can evolve potentially faster through mutations, not through sexual reproduction. whereas human beings can change and adapt through the combination of mutations and then recombination associated with sexual reproduction. The only problem is that while this is an enormous benefit, that there are clearly the costs associated with sex, which are the exact opposite of what the benefits are of asexual reproduction. In that you need to find a mate, it's very costly, energetically very costly, and if you don't want to change, it's not such a hot thing. All right, so let's make a connection here then between sexual reproduction Look, that's the crappiest writing ever. That says reproduction right there. And the next thing, which is the concept of fitness. Okay? Now, the idea of fitness is an important one. I'm going to unlock and move things around here. Fitness is not the same kind of fitness that we're talking about in terms of physical fitness, although it is somewhat connected there. Fitness involves really one major thing, which is being able to survive long enough so that you pass your genes on to the next generation. Okay? So if we were to try to define this concept, survive in order to pass genes onto next generation. Now that doesn't mean that you have to live long. It really just means that you're very efficient at passing your genes on to the next generation, and that they're efficient about passing their genes on to the next generation beyond them. So keep that in mind, that there's two components. It is certainly beneficial if you live for a long time, because that can help you. But if you live for a long time and you're sterile, that's not going to help you at all, because you won't be able to pass your genes on. And the sort of corollary to that is if you live for a really short period of time, but you're highly fecund, which means that you're able to reproduce a ton in that short period of your life, then in fact you have a high degree of fitness. Okay, so this concept of fitness is going to be an important one as we move through, because sexual reproduction allows you to essentially accumulate genes, potentially accumulate genes that increase your fitness. And when that happens over a period of time where you're accumulating good genes, then the population begins to shift. And ultimately, this is a process known as evolution, which we go back to right here. All right, let me pause it for a moment. All right, so now the last thing I want to talk to you about is this concept of survival of genes. And this is kind of a cool thing to think about here. This was a concept put forth by Richard Dawkins, who is a biologist. And essentially what Richard Dawkins proposed is that organisms are simply survival machines for their genes. And if you think about that, that makes perfect sense. Hold on, let me just make a drawing here. So if you have this funky giraffe turtle thing, and it's really good at surviving and passing its genes on to the next generation, fundamentally all it needs to do is do just enough to be able to reproduce. And if it decides that reproducing through asexual means is the best way to hand off genes to the next generation, and frankly the genes would really prefer that because you have exact copies of all the genes to be passed on, then of course it's going to choose that mechanism, asexual reproduction. However, if it makes more sense for it to undergo sexual reproduction, and it's not like these things have a choice, they have evolved to either be asexual reproducers or sexual reproducers. However, if you imagine that you're in an environment that's somewhat fickle or changing, which is inevitable because the environment's always going to change a little bit, then undergoing or using a sexual form of reproduction is going to pass on a higher percentage of your genes to the next generation. Because of course, let's imagine this turtle, if it could either have a choice, right? We're sort of like a game theory here. You can do asexual reproduction and 100% of your genes gets passed on to the next generation. However, imagine that in the next environment that is being faced by this turtle giraffe-like thing, all of those turtle giraffes go extinct. So now you've just lost out completely. Now 100% of your genes are not going to be passed on from that point forward. Whereas you could imagine if they underwent a sexual form of reproduction, then maybe only 50% of your genes are going to be passed on to the next generation. Of course, that would be the case because you have to take the genes of your mate as well as yourself and put them into your offspring. And yet, because of that offspring, the offspring has adapted to its environment since it was a sexual means of reproduction, 100% of these dudes survive and are able to pass their genes on to the next generation. So you have 100% of your genes where there's a 0% chance of survival, or 50% of your genes where there's a 100% chance of survival. Or at least, I shouldn't say 100. There's a higher than 0% chance because you have potentially adapted to the new environment as a result of sexual reproduction. So it's a little bit of a game that's played by organisms, and it's played out on the stage of evolution and natural selection, driving the evolution over many, many years. More like many, many millions of years. Okay, so think about this as the concept of survival of the genes, and then we work backwards to the concept of fitness is another important thing to understand, and then all the way back to the importance of sex as a way to vary what goes into the next generation, but how it's not always the best deal. Sometimes it's better to do asexual reproduction. All right, crew. See you on Wednesday. Bye.